Hello all, today we're going to be creating a short basic introduction to using the Text2Image tab within Stable Diffusion and the automatic 1111 user interface. We'll start with our positive prompts. So if we type in a lady, we can see that it generates us a lady, but it might not be exactly what we want. So if we give Stable Diffusion a little bit more information, we'll have a young lady with blonde hair in Central Park wearing a scarf on an autumn day, portrait style, 8K, realistic and detailed. We should get something a little bit closer to what we want. And here you can see that's a lot more detailed by giving Stable Diffusion some more positive prompts. We also have negative prompts, which, as you can guess, is the opposite of the positive prompt. This tells Stable Diffusion what we don't want. So if we say we look at our image and we've got a yellow scarf, we can say we definitely don't want a yellow scarf. And by adding parentheses around the words, this gives it more focus to tell Stable Diffusion we definitely don't want a yellow scarf. So if we generate the image, you can see now it's generated a similar image, but now we have a red scarf and it's listening to our prompts, both positive and negative. If we come down to the sampling method, there are a lot of sampling methods that can be used. Euler is the default, and I'd suggest as a beginner that's a pretty good sampling method for most beginner cases, but the fun is playing around with all the different sampling methods to see what type of different images you can create. We have the number of sampling steps, which effectively is the number of times that Stable Diffusion will iterate over your image. For example, if we set the sampling steps to 1, then we're going to see a lot less of Stable Diffusion taking in all of our prompts. So if we run that, we get this twisted image here, a bit weird. And so I would suggest using sampling steps between 7 to 20 is typically where we want to be. And by setting it back to 20, we can see we're getting back a much more detailed image. If I scroll down and look at the next 3 checkboxes, we have Restore Faces. This effectively does a small fix at the end of the image generation. It will smooth out the face. It will give a little bit more detail to the eyes, because sometimes you can have deformities creeping in. So Restore Faces is very useful, especially when you're working with faces. The Tiling tab is used for creating repeating patterns, so it's not necessarily something you'd want to do on this image, but if, for example, we were looking at a jigsaw maybe, and we included the tiling, we will see the following. And you can see we start getting repeating patterns creating our image, so there's a lot of fun to be had with that. The high-res fix, essentially the resolution by default, the width and the height of the image is set to 512. You can increase this to a higher resolution, for example 2048 by 2048. The only difference here is that will take a lot more virtual RAM processing power, and it will take a lot longer to generate the image, and depending upon the graphics card you have, you might not even have enough virtual RAM to be able to create that. So our high-res fix is a little cheat that does a small upscale at the end of the image generation, and so we can generate higher resolution images without risking duplicating characters and again deformities creeping in. So another really useful one. We have the batch count and the batch size. Effectively, the batch size is the number of images that we want to generate. The batch count is the number of batches we want to generate. So if we set that to a batch count of 2 and a batch size of 2, we should now generate 4 images. And as you can see, we get our 4 images of the jigsaw that we're trying to create above. Let's put our young lady in Central Park back. We'll change this back to 1 and 1. The CFG scale, this is the classifier free guidance scale. This effectively tells Stable Diffusion how much emphasis we want to place on the prompts that we're giving it. So if we set that to 1, for example, then we get an image, but it may be missing off maybe the emphasis on an autumn day or the 8K element. So again, CFG scale defaults to 7. I tend to range between maybe 7 to 15, 16 as a guide when I'm using this. We have the seed number here, so effectively Stable Diffusion will create some metadata within your image. So if we select on this image, we can see there's a seed here. The seed number is unique to every single image that's generated in Stable Diffusion. If we copy this seed number and enter it here, Stable Diffusion will base the new image it generates on the previous image using this seed number. So if we generate this, we should hopefully see a very similar image to the one that we have here. Similar enough. -1 is a totally unique image. It won't be based off any other images. And there we go again. And then control net I won't go into today because that's probably an advanced topic. So the last one I'll mention is the XYZ plot script, which is really useful because when we were talking about different sampling methods, we can test them against each other, and it will help you find out which sampling method suits the image that you're trying to generate. So it's a really good test. So here, if we say we'd like EULA A, and they're separated by commas to do more than one, we'll have LMS, which is those two, and we'll say, let's say the number of steps, we want to go from 6 to 10, and we want to increment by 2 each time. So this will effectively give us steps of 6, 8 and 10 run against EULA A and LMS of the sampling methods. So if we generate this, so we can now see this really cool image that says on step 6 EULA A versus LMS. We can start seeing the differences. EULA A tends to kick in around step 7, so we can see that's a much more clear image, and then the more steps we use up to a certain point will give us that extra detail. So I think that's about it for the initial text-to-image tab. Have fun with it and let me know if you have any questions in the comments. Cheers guys.